You know that feeling, right? You've built a piece of software, you think it's perfect, and then, bam, it crashes and burns. Yep, we've all been there. Today, we're going to talk about how to deal with that, the art of failing gracefully, using a really powerful technique called exception handling. It's kind of the secret sauce for building software that doesn't just work, but is actually tough and resilient.
Ah, yes, this old friend, the divide by zero error. It's the perfect example of how a program that's perfectly logical can just stop when it's asked to do something impossible. And here's the thing. This isn't about you writing bad code. It's just about reality being unpredictable. And this is exactly why we need a solid plan for handling errors.
So that brings us to the big goal, reliability. I mean, what does that even mean? A reliable program isn't just one that works when everything's perfect. No, it's one that keeps its cool even when things go wrong. It has to work under all conditions. So the real question is, how do we build our software to expect failure and handle it with grace instead of just panic?
Okay, to really get why the modern way is so much better, we have to look back at the old way of doing things. And honestly, it was kind of messy. Programmers used to have to manually check for every possible problem at every single step.
And this quote right here, it just nails it. When you have to stop and check for an error after every single line of your main code, the whole thing gets incredibly cluttered. It's hard to read, hard to follow. Imagine trying to tell a great story but having to pause after every sentence to say, "You still with me?" The story just gets lost.
And here you can see exactly what I mean. Just look at this. On the left, that's the old way. You see how those if-error checks are just tangled up with the main logic? It's a mess. But on the right, wow, the main tasks A, B, and C are crystal clear. And all the what-if stuff? It's tucked away neatly in its own section. The difference in just being able to read this is it's night and day.
So, this much cleaner, much more organized way of doing things is called exception handling. And it's a total game changer. It's a whole different way of thinking. You stop defensively checking for errors everywhere, and instead, you create a clean separation between your main job and your emergency plans.
So what is an exception really? The best way to think about it is like a fire alarm for your code. It's a loud, clear signal that something unexpected and serious just happened. Normal operations have to stop right now so we can deal with the emergency.
And, if the exception is the fire alarm, then the exception handler, well, that's the fire department. It's a special piece of code that's trained and ready to go for one specific type of emergency. Its job is to show up, contain the problem, and handle it safely. So here's how it all plays out. First, some error happens. Second, your program stops what it's doing and raises the exception. It pulls the fire alarm. Then the system immediately looks around for the right fire department, a handler that knows how to deal with this specific problem. And if it finds one, that handler takes over. It's a really clean, orderly way to manage total chaos.
Now, theory is great, but let's see how this works in the real world. We're going to take a look at a programming language called Ada. And Ada is famous for having a really powerful and, frankly, elegant system for handling exceptions. It's the perfect case study. One of the coolest things about Ada's approach is that it keeps things local. What that means is the code to handle an error is put right inside the same block of code that might cause the error. It's kind of like having a fire extinguisher in every room of your house. If a fire starts, you know exactly where to go.
And this is what it actually looks like in the code. You've got your main logic between begin and the exception keyword. Then, after exception, you list your handlers. That when part says, hey, if this specific thing goes wrong, run this specific code. It's so simple and so effective.
Okay, but you're probably wondering, what happens if there's no handler for that problem right there? What if there's no fire extinguisher in this room for this particular fire? Does the whole program just crash and burn? Well, no. And the answer reveals something really, really powerful.
This is where the magic happens. It's called propagation. If an exception isn't handled right where it happens, it gets passed up the chain of command. It goes to the function that made the call in the first place. It's basically like escalating an issue to your manager, who might escalate it to their manager until it finds someone who knows how to deal with it.
Plus, Ada is smart. It comes with a whole set of predefined exceptions for all the usual suspects. Things like trying to access an array with the wrong index or running out of memory. This saves you from having to write emergency plans for every common problem because they're already built right in.
But here's the best part. You are not stuck with just the built-in ones.
Ada lets you define your own custom exceptions. You can create emergency signals that are perfectly tailored to whatever your application does. This means you can build an error handling system that is as unique as your own software.
So, we've walked through the what and the how, especially with Ada. But let's zoom out. What's the real payoff here? Why is this whole approach such a big deal for building good software?
Well, it really all comes down to this. You get to separate your main happy path logic from your what-if error logic. That alone makes your code so much easier to read and maintain. And with propagation, one single handler can take care of errors from lots of different places. All of this adds up to one thing: way more reliable software. So I'll leave you with this thought. Maybe building great software isn't about trying to prevent every single error from ever happening. Maybe it's about accepting that things will go wrong and planning to handle them with grace. So, what exceptions does your next project need to be ready for?